Peeking into the internal progress of Vacuum with that system view is a great segue to the topic of system views in general. System views provide a way, really a glimpse into the internal workings of Redshift. With a little research, you'll find that Redshift is actually keeping logs on all sorts of information, and tables full of other types of information. And then through views, you can access a snapshot glance of everything from active sessions to those vacuum queries that we showed. So for clarity's sake, from here on out, when I say system views, I'm encompassing all system views, logs, tables, and even the catalogs that Redshift inherited from its Postgres ancestors, the ones that have the PG prefix. Now the naming convention is worth mentioning for identifying where the data is coming from. STL are system table logs, places where Redshift stores information deemed useful. STV are system table snapshots, places you can get a glimpse of something happening right now. SVV and SVL prefixes are views that join or enhance those tables further. And like I mentioned, PG are the system catalog tables in the engine that remained in place from the original Postgres source code. Like those we saw with Vacuum and Snapshot, there are many more system views that give you all kinds of information and insight that could be critical to monitoring and understanding your environment. There are views that would allow you to enumerate tables or users, identify errors like we saw in the first module, see past queries, inspect query plans, and a lot of other important tasks. In our previous module, we talked about putting together a security audit. Leveraging system views, for example, we could run something like this and get a list of all users, what objects they have rights to, the groups that they are a member of, and create these as a report. Since these views are accessed right through the SQL language, you could wire them up to any good BI tool and run and schedule that health and monitoring right on your cluster, just like you would a regular business report. Both internal and external auditors love things like this, especially when you can show them the source SQL. To access the documentation for all of your system views and tables, go to the System Tables reference, and it, as well as everything else we've talked about, is found in the Amazon Redshift Database Developer Guide. In our final demo of the course, let's go through a few more system views in order to show how you could leverage them to set up logs for ongoing monitoring and auditing of your cluster in other ways. Let's consider this demo as a way to just pique your creativity in identifying the wide world of possibilities. Now, some of the really useful ones you don't even have to write yourself. The user rights query I showed you, for example, actually comes from a library of pre-written queries against these system views that the AWS Labs team has already authored and released as open source out on GitHub. I showed the link before, but here it is again just in case you missed it. Now, this GitHub link is a fantastic resource, not only for getting your hands on some very informative queries and functions, but is a great tutorial on how to leverage many of the views that are out there. Seeing as you can download the queries right from GitHub, you can also modify them to your specific need. There may be many circumstances where you have a specific type of information that you'd like to track and monitor over time. For example, this is a query from the AWS Labs that I modified slightly to gather performance statistics of queries. Using any number of BI tools, I can schedule this as a report and get a daily snapshot of the performance of my cluster right to my inbox. Or using a query like this one where I get the columns relative to a table and storage details together with a count of available rows so that I can obtain information to assist me in identifying how many deleted rows exist in a table that would be removed by a vacuum process. Now, one useful audit you might want to perform is identifying what tables and objects have dependencies on other tables and objects, or what tables are referenced in a view. These are also available from the AWS Labs GitHub page, again extremely useful when planning updates to schema or enhancing existing code. The sky is literally the limit with what types of information that you can glean from your clusters. Even more when you start digging into the CLI that can reveal programmatic access to the APIs that AWS provides. Now, another critical command that, while not a system view, is very powerful is the explain command. This will reveal to you query plans, which is a critical tool in the toolbox of any data architect or data tuner. This pro technique is accomplished by simply adding the explain keyword prior to the SQL statement that you would like to analyze. What returns is the query plan, or the step-by-step physical operations that Redshift is going to take to acquire your data. Digging into the content of the return results is material for another course, one I'll be releasing shortly, by the way. But there are also a good many other resources out in the wild on analyzing query plans and determining bottlenecks or areas for improvement.